Welcome back. Myself, Mrs. Felina Gonsalves, teacher Shitvidya Mandir, English High School, Maharashtra Board, Vasai. Today we are going to learn chapter 18 of Science for Standard 7th. The topic is sound. What is sound? Sound is created when something vibrates and sends waves of energy into our ears. The vibration travels through the air or another medium, that is solid, liquid or gas. The stronger the vibration, the louder the sound. For example, when a school bell rings, part of the bell will vibrate, creating sound. Observe the picture given below. You will notice that sound is generated due to a variety of events. Sound was generated due to vibration of an object, for example, the bell or the string or diaphragm of a musical instrument, while in some example like bursting a cracker, clapping, a lightning strike, vibration are not actually felt. However, vibration are produced in those cases as well. All this vibration are imparted to the molecules in the air and sound is produced. You might have seen that when a stone is thrown into the calm water of a lake, waves are generated and they reach up to the bank of the lake. Vibration reach our ears to the air in a similar way and the sound is heard. When a singer tunes the musical instrument before he starts singing, what exactly does he do? He ensures that the tempura which produce the required notes by adjusting the tension in the string. That is, he tunes the tempura. A tabla player tunes the tabla by hammering the pedal to adjust the tension in the diaphragm of the tabla. The harmonium accomplished find out beforehand the key in which the singer will sing. To tune an instrument is to adjust how high or low the pitch of the notes produced will be. The pitch of a sound depends upon its frequency. In Indian music, the musical notes sa re ga ma pa da ni sa are of increasingly higher pitch. In scientific term, frequency is a measure of pitch. What is periodic motion? The object moves to one side of the central position and comes back to the central position while vibrating. This motion of an object is repeated again and again at fixed interval of time. Such motion of an object is called periodic motion. For example, when the string of a musical instrument such as a tempura is plucked, the string can be seen to vibrate, but the two ends of the vibrating string are still. As it vibrates, the string moves to one side of the central position and comes back to the central position. This motion of the string is repeated again and again at fixed interval of time. Now let's know about simple oscillator or simple pendulum. The object moving from one end to the other end of its central position again and again in fixed interval of time is called a simple oscillator or simple pendulum. A simple pendulum consists of a mass hanging from a string of length and fixed at a point. When displaced to an initial angle and released, the pendulum will swing back and forth with periodic motion. Let's know about oscillatory motion of oscillator. The back and forth motion of an oscillator on either side of a central position is called oscillatory motion. For example, a swing that comes back and forth like this is an oscillator. When the swing moves from one end to the other and returns to its starting point, it is said to have completed one oscillation. Aptitude. For this, let's try this experiment. Take an empty porcelain bowl or an empty steel glass, stretch a rubber band and fix it on the bowl or glass as shown in the picture. Now give a jack to the rubber band. Repeated action applying a smaller or greater force. While doing this, observe the faster distance to which the rubber band is stretched. Note the sound generated. When the rubber band is stretched and released, it vibrates. Compare the vibration with the figure alongside. When the rubber is stretched from the original position A and comes to position B, it is seen to be curved. So we can say that the maximum distance between the original position A and the position B on stretching the rubber is called the amplitude of vibration. Now let's know about pendulum. An oscillator which is made up of small iron or wooden ball tied to a half a meter long and strong thread, and the other end of the thread is tied to a fixed support such that the ball is freely suspended in the air. Such an oscillator is called a pendulum. Elasticity. A stretched rubber returns to its original state when it is released. This property is called elasticity. When a stretched rubber band vibrates, elasticity is at work. All the while that the pendulum oscillates, Earth's gravitation is at work. Let's know about time period of oscillation. The time for one oscillation is called a period. It is measured in seconds. The time taken by an oscillator to complete one oscillation is called the time period oscillator. Time period is denoted by letter T. Time period is measured in seconds. Now for example, the oscillator travels the distance from the extreme position B to central position A and from there to position C. Then comes back again to A and from A to B. The time required by the oscillator to traverse the distance, that is BAC or AB, is the time period of oscillation of the oscillator. What's its frequency of oscillation? The number of oscillations completed by an oscillator in 1 second is called the frequency of oscillation. It means, thus consider an oscillator completes 20 oscillations in 1 second, then the frequency of the oscillator is 20 Hz. The term used for frequency is N. The formula frequency is 1 upon time period of oscillation, that is 1 upon T. For example, frequency of 1 Hz means 1 oscillation in 1 second. Frequency of 100 Hz means there are 100 oscillations in 1 second. Now let's know the interrelationship between length of the pendulum is period of oscillation and frequency. The time period of oscillation depends on the length of pendulum. As the length of pendulum increases, the time period of oscillation increases. As the length of pendulum decreases, the time period also decreases. The frequency of oscillation also changes according to the changes in the length of the pendulum. Frequency decreases on increasing the length of the pendulum and frequency increases on decreasing the length of pendulum. The time period of oscillation of a pendulum does not depend on its amplitude. Also, the frequency of oscillation of a pendulum does not depend on its amplitude. That means, even if the amplitude changes, the frequency does not change, it remains the same. Copy down the following assignment. The topic of audible sound, infrasonic sound and ultrasonic sound will be continued in the next video.